Hello everyone, thanks for joining me. So today we're going to be looking at composite shapes. Now, this word composite, before we even start kind of explicitly defining composite shapes or looking at what they are, let's just look at this word composite because we know what shapes are, but this word composite, what does it sound like? What other word does it sound like? Now, some of you may be thinking of the word composed. Oh, can't spell. Composed. Composed or composition, something like that. Now, when I use the word composed, a lot of the time mathematical vocabulary pulls from our regular vocabulary, but some of these words have double meanings. So when I say composed, in this context of composite shapes, I don't mean composed like I'm calm and composed. I'm thinking composed more as a composition. Say, let's think of what that means. Well, for example, Mozart composed all of these classical works. Some writer composed their literature. When we talk about a composition or something being composed of something, we think of, well, it's made out of something. Out of something. And this definition that we've laid out, this idea of something being composed, something being made out of something, this extends to our idea of composite shapes. Our composite shapes are these new types of shapes composed of other shapes. So we take the shapes we actually know and we compose new shapes out of them. Now, I'm going to draw a composite shape which may look familiar to you. It's probably, to me, I'd say, the most common composite shape because we spend a lot of our time around these things. And this is a very elementary kind of primary school drawing of a house. This is probably how you would have drawn a house when you were a kid. And a house, at least in this sort of childlike drawing context, this is a composite shape. We have one new shape, the shape of our house, composed of two known shapes, two pre-existing shapes. We have a triangle here and we have a rectangle here. Now, some houses can be squares, some can be rectangles, but the idea I'm trying to get at is that, well, our house here is a composite shape. So this is a plane shape I've drawn. So this is just a 2D shape. So we can start looking at the area of this composite shape. So we can say two areas here, right? I have an area here, the area of the bottom bit of my house, and I have the area of my roof. So I'll write area 1, A1, and I'm going to say here, well, roof / triangle, because that's the shape it is. And I have my second area, my A2, which is the, let's say, base / rectangle. Now, this is a composite shape. So if I wanted to find the total area of this shape, well, I'd find one, say this one. I would find a second area, and we're looking for the total area these two make up. And this total area is the area of our composite. So we can say that in this context, our area of, I'm going to put this little subscript C for composite. So our composite area equals our total area. Or another way to write a total would be, well, adding our two areas. So that would be, say, our area 1 plus our area 2. So the basic composite shapes we deal with, something like this one, for example, will be, well, finding the actual area will just be summing the total areas. And you may find that a lot of questions you could come across have these kind of really weird sort of shapes, something like this, or, you know, this little kind of shape like this. And these aren't shapes that we're typically used to, but these are just different types of composite shapes because these can be split into shapes that we already know, and they can be done in numerous ways. So we have this, for example, or we could, oh no, I'll just undo all these. We could have this shape and this shape, or something looking like this, but we're going to get the same area when we calculate it. No matter which way we break it up, which kind of orientation of shapes we choose, we will still have the same area making up our composite shape. So hence, in the context of area, our composite shapes are their areas calculated by the sum of the areas of the shapes that make this up. So in the context of this, we had the area of a triangle plus the area of a rectangle. And the same thing goes for volume, because if I were to draw my house, but this time in 3D, and this looks more like a hut, honestly, but you would just have to deal with, no, I'm just going to try that again. That's pretty shocking. If I did this same thing just in 3D, well, the kind of composite volume and go up there. This type of composite volume will still be just a sum of respective volumes, because we'd first just find the volume of our roof here. So we take our kind of cross-sectional area, multiply it by its depth, and we get one volume. We get the volume of our roof, for example. Then we can also find the volume of the rest of our house. And once again, cross-sectional area multiplied by the depth. And we can find composite volumes as well. So you may notice a trend here, and that is that when we have any composite shape, any shape that we can make out of pre-existing shapes, we can find its area or volume by breaking it into components, breaking it into the shapes we know. For example, here we have a rectangular prism and a triangular prism as well. In this example here, we can just find each unique volume and then add those together. There's no other way around finding composite shape areas and volumes, because we don't have a formula for a composite shape, but we have a formula for finding areas and volumes for those shapes that make them up. I hope that makes sense. This is just a quick video to give you an introduction into composite shapes, which we'll be working with a lot more in future years. But for the time being, that is all we need to know. I'll see you next time.